right, so now we're going to be looking at the graph and how we graph secant, cosecant, tangent, cotangent, and those different functions. So it's a little different, but it's actually very similar, especially secant and cosecant. It's very similar with what we've been doing already. So by the end of the time today, and actually I'm going to break this up into two videos. We're going to do one video probably on secant and cosecant, another video on tangent and cotangent, which is a little bit different than that. So we're going to start with the graph of secant and cosecant. To do that, we're going to remind ourselves, how do we graph sine and cosine? And we've been working with them so much. So here we'll do sine in blue, that the sine is just there. There's our sine curve. Our cosine was in red. Our red would start here, come down to the highest, and come back to the highest. All right, so we have to know, you just have to know how sine and cosine, how the curve of sine and cosine works. So what we actually do here, we have a kind of a nice little process that we do. What we're going to do is we're going to start off by lightly sketching the sine or the cosine curve. And then from there, we're going to work on wherever the sine or the cosine curve is 0, we're going to work on kind of doing the inverses. The cosecant or secant will be undefined. So we're going to be looking at that, and we're going to be looking at this inverse function. So first, let's just talk about here. We're going to start with secant. And so with secant, what we're going to do is we're going to start by, and I'm going to do it in red here, I'm going to graph the companion function of secant, which is cosine. So I'm going to start with, how do we graph the cosine? So what I do is I'm going to graph my cosine curve. So there's my cosine curve. I hope I gave myself enough room here. You'll see why I said that here in a minute. I think I'm going to move that down. Okay, here, 1 second. I got to move some things out of my way here. All right, that was really out of the way. You'll see why here in a minute. All right, so we have our curve. We've sketched it there. And what happens is for each one of the points that are along our curve, each one of these points, in each kind of the curve, we kind of do the opposite when it comes to secant. So I'm going to bring this down here. All right, kind of out of my way. That's what we have in red. So I'm going to do this in blue here. I'm going to do my secant. What happens is instead of coming down like it does here in red, what happens when it's blue is it goes in the opposite direction. Okay, so it kind of is like just the opposite, and actually technicality this would go in that direction. But what happens is when it crosses a 0, all right, so when we have a 0, what actually happens in the secant is like this would be 1 over 0. Well, we can't divide by 0, so what happens is called an asymptote. And so I'm going to have there an asymptote, and I have here another asymptote. It's supposed to be this straight line. And so the graph actually just kind of goes and follows that asymptote and is almost like repelled by the graph that's in red. So there would be my graph in technicality. This goes up here. All right. So if I wanted to say, okay, just show exactly one cycle, I'm going to show you where exactly one cycle. I wouldn't have that. This would be exactly one cycle. So it starts here and it goes up, and this is kind of its companion, and it goes up here. And this is my cycle. So that actually is the graph of the secant of x. It's kind of, you take the cosine of x and do the exact opposite. It's like almost like repelled in the opposite direction. And that's the inverse. So wherever we have points here, it's always that inverse. So this is the point 1. Inverse of 1 is still 1. This might be the point, let's say it is 0.707, okay? The inverse of that, 1 divided by 0.707, gets higher, okay? And so that is actually like 1.4. All right, so this would be the 1.4. So it kind of just goes in the opposite direction here. All right, it keeps going in the opposite direction. Same thing here. At -1 is still -1. You take the inverse, but then when you take the inverse of the other values, it just goes in the opposite direction. So now let's look at the same idea, but we're going to look at it from the idea of cosecant. So what we do with cosecant, now I can move this up a little bit. I'm going to make it a little bit wider. With cosecant, we're going to start by graphing y equals sine. So we're going to start here by graphing our sine equation. So let's I'm going to be smarter and go a little smaller there. There's my sine equation. And then now, my next step is wherever I go through 0, I'm going to see it, and a lot of times I'll do this in dashed. Actually, I should probably do it in dashed. I'm going to know I'm going to have an asymptote. So wherever I have these zeros, I know I'm going to have an asymptote. In other words, my cosecant will never cross that. It'll approach it, but never cross it. And so my cosecant now, I'm going to do in blue here, would just kind of gets repelled, would go in the opposite direction. So here I always start here, and that's my cosecant. Okay? So let me show you another example. So here, what I'm going to do first is I'm going to graph the equation y equals 3 sine, sine is the companion of cosecant, of that 1/2 x minus pi over 8. So I have to graph all of that. So my vertical shift is the same visual. I have a vertical shift of 0. I have an amplitude of 3. My phase shift I need to calculate, so I need to go 1/2 x minus pi over 8 equals 0. So 1/2 x would equal pi over 8. Multiply both sides by 2. X would equal pi over 4. So my phase shift is pi over 4. My period, I'd have to take, to get my period, I'd have to take 2 pi and divide it by my k, divided by 1/2. 2 pi divided by 1/2 is 2 pi times 2 over 1. My period is 4 pi. So first thing I would do here, I'm going to kind of move this over a little bit here. Make that maybe a little bit bigger. Okay, first thing I do is say, okay, here's my 0. Here is my amplitude is going to go up to a highest point of 3 and the lowest point of -3. Excuse me. And then we are going to graph this. So usually our period, and I'm going to have to maybe move this down here a little bit, is usually 4 pi. Half of that is 2 pi. Half of that is 1 pi. This would be 3 pi. Now, our phase shift, it's moving over just a quarter. So where usually our sign here would be here, and it would be like that. We're going to move it over just a quarter. And so we're going to be here, and every little point that we have is going to go over just a little bit. All right, so here's my new curve. There's my new curve. Everything moved over a quarter. This is 2 1/4. This is a fourth. This is 1 1/4 right up here. This is 3 1/4 right here. So everything kind of moved over a quarter. And what happens is you just look at this and say, okay, where it was a 0, I am now going to have an asymptote, a vertical asymptote. And I'm just going to draw a straight line here for my vertical asymptotes. And I'm going to draw my vertical asymptote there at a fourth. And then you just have to draw, I'm left with black here, you just have to go and draw your cosecant. So my answer here is actually what's in black. So that's my answer. That's the visual of the cosecant of that. So it's all about first drawing that you have the sign, and then you draw your cosecant that kind of matches. Okay? Let's do another example. All right, secant. For this one, what I'm going to do here is I'm going to first graph y equals 1/2 cosine of 2x plus pi over 4. Okay, so our vertical shift is still 0. Our amplitude is 1/2, so it's going to go up to a half and down to a -1/2. Now I have to calculate my period and my phase shift. My period equals 2 pi divided by my k divided by 2. So my period here is pi. So my period is pi. My phase shift, I'm going to get in the way here. I got to kind of find spots to do this. Sorry, guys. I'm going to move over here. My phase shift is going to take what's in parentheses, 2x plus pi over 4, and set it equal to 0. Therefore, 2x would equal negative pi over 4. Dividing everything by 2, x would equal negative pi over 8. So I have a phase shift of negative pi over 8. Okay, so usually here, from between my period would be between 0 and pi, and then here I'd have half a pi or pi over 2, a fourth of a pi or pi over 4, and here this would be 3/4 of pi. All right, so usually when we have cosine, if I had my cosine, it would look like this. Now I have to shift it to the left by a -1/8. So I might come to myself and say, okay, let me cut this into eighths here. so it's easier to shift. So for every one of these points, I'm shifting it 1/8. So this would start at negative 1/8 or pi over 8. Instead of it crossing here, it's going to cross here. Instead of it being at the lowest point here, it'll be the lowest point here. It crosses here. Instead of being here, it's going to cross here. So here is my, in blue, cosine curve. All right. Next thing you do is wherever it crosses the 0, you make an asymptote. So I'm just going to make my asymptotes here. And then you kind of just do the opposite. I'm going to do it again in black. This is where it starts, and the opposite would be it goes up there towards your asymptotes. You go here, and you're going to go on either side towards your asymptotes. Here you go on either side. In technicality, on a technicality, it still goes over here, but we're only wanting to show one. So in a technicality, it's still going in that direction, but we only want to show one cycle. So if we're going to start here, and we're going to show one complete cycle, so one going up, and then the complete going up and down, and then kind of the other side going up, that's our complete cycle. And so that's why we kind of only show like a snapshot of our curve. So our cycles, where we have going up, going down, I could have just as easily done this and shown that cycle and gotten rid of this here. So that's another option I would have, is if I wanted to show a cycle and I wanted to show complete cycles, I could have done it like that. It's kind of your choice. Usually what we do, we stick really close to what we have for what we already had here for our cosine curve. And that's why we would have this way and get rid of this instead, because we stick close to what we had for our cosine curve. So basically, that's how we do those cosine and sine curves. Let me do one example. I think I have time here for an example from our problems. So let's look at here. Oh, we actually start with graphing this cosine. So in the first example, I said, okay, first go ahead and graph that 3 cosine 2 x minus pi over 4, and then graph it when there's a secant. So let's look. The vertical shift would be 0. My amplitude is 3. My phase shift. So let's look at my phase shift. I have to go x minus pi over 4 equal to 0. X would equal a positive pi over 4. So my phase shift is positive pi over 4. My period is 2 pi divided by my coefficient 2. My period is pi. There. All right, so we start at 0. We have a period here of pi. Halfway would be pi over 2. Half of that is pi over 4, 1/4. Half of that is 3 pi over 4. All right, so if it was the cosine curve, there's my cosine curve. But now I have to do my phase shift. I'm shifting everything 1 unit, or not 1 unit, but 1/4 to the right. So instead of starting here, I'm going to start here. I shouldn't do it in black. I'll do it in red. I'm going to start here. Instead of it being the lowest point here, it's going to be at the lowest point here. Sorry about that. Instead of being at the highest point here, it's going to be at the highest point here at pi and 1/4. All right. So let's do that. So there's my curve here. All right. Next step is wherever it crosses 0, we put the line through it. So wherever my red line crosses 0, I'm going to put the line through it. And now finally I'm going to draw the secant. So there's my secant here coming down. For this one, my secant kind of goes up like that, and for here it goes up like that. Again, on a technicality, it's still over there as well. It's still over here. We just don't usually show it. We're going to show one cycle. So good luck with this. We'll be covering it more in class, and look for the next video for tangent and cotangent.